Question number 6 from section 3.1, quadratic functions, asks us to graph the quadratic function and give the vertex, axis of symmetry, domain, and range. Because this is in vertex form, you can pick out the components of the vertex by looking at the numbers that are in the parentheses and outside the parentheses, because it's in the form of x minus h quantity squared plus k. So this plus 1 here means that the basic parabola has been shifted to the left one, and the plus 2 on the outside of the parentheses indicates that the parabola has been shifted up 2 units. So our vertex, normally at the origin, 0, 0 is it's been shifted to the left 1, which means -1, comma, up to +2. That is our vertex. And you can pick that out by looking at the components, the way it's written in this form. Let's check our answer. Now we want to find that axis of symmetry. That axis of symmetry is always a vertical line for a quadratic function that goes right through the vertex. So the axis of symmetry is a vertical line, and the vertical line is always an x equals a number equation, and the x equals the x part of the vertex. So that is going to be the equation of our axis of symmetry. It's that vertical line that goes right through the vertex. The domain. For the domain of a quadratic function is all real numbers, because you can plug everything into this quadratic function, and everything, any positive number or negative number you can plug in for x, and you can get something out of the function. Looking at the graph to determine the domain, that parabola is going to keep getting wider and wider and wider, so the domain goes from -infinity to infinity. Let's check our answer. From -infinity to infinity, we have our domain. Now the range is how low the graph goes to how high the graph goes. When we think about graphing this, the vertex is going to be at -1, +2, and we know it's going to be a parabola that opens up, because it's a positive quantity of x plus 1 squared. So the range would indicate how low the graph goes and how high the graph goes. The range for this problem is going to be the lowest y value is going to be +2 to the highest y value is going to be infinity. So from 2 to infinity, that's going to be our range, low to high. Okay, now we want to choose the correct graph. We want to choose the graph that has the vertex at -1, 2, and it opens up. Now if we look at all the choices, there's 2 that open up, and it looks like this one here, the vertex is -1 up 2. Each of these boxes is counted as 2 units. We're going to select that and move on to question number 7. For this one, we want to graph the parabola and determine the domain and range. Now, this one is not in the vertex form, so the way you find the vertex is by determining h, which is -b over 2a, and then to find k for the vertex, it's going to be f of h. And that's going to give us our vertex, which is h, k. So in this quadratic function, because it's written in the form of ax squared plus bx plus c, we can tell by looking at the equation that a is equal to 1. That's going to be our coefficient in front of the x squared. B is equal to negative 2. That's our coefficient of the x term. And C is equal to negative 2. By plugging in the values for B and A into this, we definitely want to memorize this. This is a nice way to find the vertex if the function is in this form rather than the vertex form. So our H is going to be the opposite of B, that's opposite of negative 2 divided by 2 times A. So 2 divided by 2 is going to be 1. So that's the first part of our vertex, 1 comma something else. To get that other value of the vertex, you take 1 and plug it back into the original function. So we're going to find f of the answer we got for h. We want to find f of 1. We're going to plug that back into the original equation for x. So 1 squared times 2 times minus 2 times 1 minus 2. That is going to be 1 minus 2 minus 2. Negative 1 minus 2. That'll give us negative 3. So that's going to be our k part of the vertex. So that's going to be our vertex. To graph a parabola on Mymathlab, you only need 2 points. You need a vertex and you need one other point. Well, to get that point, there's many that you can choose from. What I like to do is choose an x value that's close to the vertex x value. For the vertex, the x value is 1, so I could choose something like when x equals 0, plug 0 into the function. So I want to find f of 0. Again, plugging it back into the original function for x and simplifying, you get negative 2. So that gives us one other point on the parabola, and that point is when x is 0, y is negative 2. We're going to use the vertex and this other point to sketch the parabola on Mymathlab. Alright, so when you're in Mymathlab, click on the tool that looks like a parabola. It could be opening up or opening down. You're going to select this option here. You're going to first make a point where the vertex is. 1, negative 3, make a point. And then the other point we found by plugging in 0. You plug in 0 and you get out negative 2. So that is automatically going to create an entire parabola just by those 2 points. Your vertex and another point. The axis of symmetry is going to go right through that vertex at 1, negative 3. Save and check your answer. Now let's talk about the domain. The domain is everything that you can plug into the function, and this domain goes forever to the left and right. That parabola is going to continue to get wider and wider and wider. Extend the page here. Alright, so for our domain, as you can see with most of these quadratic functions, the domain is going to be negative infinity to infinity because the graph goes forever in both directions. From negative infinity to infinity. Now the range, you want to look at how high and how low the graph is. This is a parabola that opens up, and the lowest, the y value is there at negative 3. So from low to high, the range is low to high. The lowest that this goes on the y-axis is negative 3, and it's going to continue to move up forever. So that's going to be our range from negative 3 to infinity. close parentheses after the infinity, and check your answer.